Elle, you
Great.
can take it away.
Wonderful. Just trying to get the right screen. There we go. Okay. So first, apologies for being off camera. My desktop where I do my data doesn't have a webcam just yet. So,
No worries.
but we've got slide decks. So welcome to chapter 5 of Analyzing Baseball with Data. We're talking about value of plays using run expectancy today. I thought this chapter was really interesting. It goes through run expectancy and then talks about batting lineup, run values by bases, and the value of stealing. So first getting into the run expectancy matrix, this is an average number of runs scored in the remainder of the inning for each combination of runners and outs. So this means there's 8 possible arrangements of runners. We have whether there is or isn't a runner for each base, and we have 24 possible arrangements of runners and outs. And we'll see examples of this as we move forward. And as we create this matrix, we can use it to find the change in expected run value, really estimating the amount of runs that can happen within the plays. And we can really get into what is the relative benefit of different batting plays. So looking first at the runs scored in the remainder of the innings, we have potential for runs is our average run scored in the remainder of the inning for each combination of runners and outs. This could represent the opportunity to create runs during an inning, and it also provides a baseline to measure player contributions against, where we calculate the runs scored in the remainder of the inning by the runs in the total inning minus the runs so far in the inning. So getting into the matrices and getting some numbers going, we consider plays with a change in the runners on bases, number of outs, and runs scored. So these matrices are all about the changes. So we get the states, which is our combination of base runners and outs, in order to identify the changes and filter out the data to look at those changes. So here with the book, I very much followed the book because sports analytics is a new topic for me. So following the book, they only considered half innings with 3 outs, which to flag does introduce a small bias because we're only looking at those, but it was a good start to this. So looking at the run expectancy, which again is our expected number of runs scored in the remainder of the inning, I turned the matrix that is output from the book into a heat map because, as much fun as numbers are, visualizations make them a lot easier to take in many of them. So we'll see this coming up a lot in this chapter, but on the y-axis here, we have the bases, where that's our various states, where the 3 numbers are whether there is somebody on the base or not. So 0, 0, 0 means there's nobody on any bases, where our first is first base, second base, third base. 0 is nobody, 1 is somebody on base. And on our x-axis, we have the outs, where we have 0 outs, 1 outs, or 2 outs. So here we can see that our run expectancy is highest with the bases loaded and no outs, which makes sense. We have a lot of people on bases. We have more time to make more runs because we have no outs. I also turned this into a scatter plot just to kind of look at this in another way. The bases are now on the x-axis here, and we have the mean run value on the y. And I slightly reordered the bases to be a little more intuitive, where we have no one on bases, first base, second base, third base, and then first and second have someone, first and third, second and third, and bases loaded. And I thought this was really interesting to see this trajectory of how across the different combinations of bases, our mean run value increases as we get more people on bases and further towards actually getting a run with people on those latter bases, those second, third bases.
For this x-axis here, did you use a factor variable?
Yes, I did.
Okay, thank you.
Yep. And I know I don't have the code in here, but once I'll push the code up to GitHub and, it will all be there to see. But yeah, I changed it to a factor and adjusted that way. So we can also look at this over time, which I thought was really interesting. The book plotted 2016 and 2002, which, new at this point. 2016 comes with some air quotes, but even across this time period, we can see that the matrices don't really change much. There's very few changes in the average run score tendencies from 2002 to 2016, which is I thought interesting to see, especially given our past sessions. We've looked at things changing over time, and that's always an aspect I found interesting. So digging into this a little further and measuring the success of a batting play. So our run value, we can look at the value of plate appearance, and the state will change and our run expectancy will be updated, right? So our run value is the new state of runs minus the old state of runs plus the runs that were scored on the play. So a few caveats with the data handling that the book discussed was that we match the expected run values for the beginning of each plate appearance by matching the bases and the outs to our run expectancy matrix. That's how we get everything all together. We match the new bases and new outs to the run expectancy matrix. We set our values with 3 outs down to 0, and therefore we can end with a run expectancy of current state, run expectancy of new state, and the difference of our run expectancy of the current state and the new state plus the run score. So as we'll see, this really lets us dig into what happened in each of the plays by looking at the current state versus the new state. So looking at a single player, Jose Altuve, if I'm pronouncing that incorrectly and somebody knows better, feel free to correct me there. But we started to look at batting plays where Altuve was the hitter. And our first big question was, how did Altuve do in his first 3 plate appearances in the 2016 season? The book didn't mention this, but I Googled it because I am not familiar with all players from all times and all seasons, but he was part of the Houston Astros in the 2016 season. So like we just mentioned on the first slide, we have our current state here. Our new state is our second column, and then we get that run value. So for the first plate appearance, no one on bases, 1 out, and it ended with no one on bases and 2 outs, meaning that Altuve got out during that play. His second appearance, again, no one on bases, 1 out, and then he did get on first base, and we still have 1 out. Makes sense. Gets on base, not out. And then the third is no one on bases and 1 out. And again, no one on bases, 2 outs. And we can see that this run value, whenever he gets on base and we don't have an extra out, that run value is positive of 0.24, as opposed to when he does get out, we get a negative run value of negative 0.162. So 2 of the primary questions that this assessment of run values can really help us answer or what were the runner out situations for the player's plate appearances? And then what did the batter do with the opportunities to score runs? So looking deeper into the runner states to understand opportunities, the book first outputs this table where we look at all of the different base states and the frequency of each of these occurrences. We can see most often the batting with the bases empty or with a runner only on first. The book also made this nifty plot that I added color to, and because Jose Altuve was on the Houston Astros, I made it blue to orange in those colors. So we can see that when the bases are empty, the ranges of runs is small. With the extra flag, this orange box here with a run value of 1 is indicating a home run. And that will come up a little later on as well. But bases empty, we have a small range of runs. But in other situations, we have much more variation, especially as we get to these latter instances of someone on first and second and the bases loaded. I thought this was really interesting to see how, again, the change in the runners on the bases really impacts that run value and, the opportunities. So that was just for instances. We can also look at the total run production for 2016. Again, we're still looking at just Jose Altuve, but we can look at the number of opportunities and some of the run values for each situation. These first two columns of the bases and the PA is the same as above, where we have the frequency for each of the bases. But now we have the total run values, which is the sum of the run values. I thought this was interesting, particularly because just looking at the sum, your higher frequency instances are going to have higher values since you're summing across more, instances. So the total contribution at bat with bases empty is 10.1, followed by somebody on first with 10.2. Again, those are higher frequency instances. And he didn't do so well with runners in scoring positions, particularly somebody on second and with the bases loaded. So we can then look at the total contribution for his 2016 season, looking at the run expectancy change over the 24 base out states, which we initially talked about in the beginning. And again, we're summing the total here, and we get the run expectancy for the 24 base out states as 34.7. Which is great. Always fun to have numbers, but we should look at more people, right, in order to put this into perspective. So that's what we are doing next. I went through a few slides there, so I'm actually going to take a pause, see if anyone has thoughts or questions up to this point, which can go in the chat or out loud. Okay, great. So next, we're looking at the opportunity and successes for all hitters, really put things into perspective with more players. So again, we're comparing runs to estimate player batting effectiveness. So one of the big things to flag here is that different players have different opportunities to create runs. This can be based on batting order, right? Depending on where you are in the batting order can alter the amount of people that are on bases. First at bat, top of the inning, there's not going to be anyone on bases. So you really don't have that opportunity. that somebody more at third, fourth bat would, which we'll look a little deeper at later as well. So looking at performance by season, we can look at the total number of plate appearances, the sum of run potentials, and the sum of run values. That can hopefully give us a general view of these opportunities and what are done with the opportunities, the effectiveness. So the book focuses on batters with 400 or more plate appearances. This was their way to look less at pitchers. And again, here's the book code, and we get just the head of that data frame. So we get each of the batters, the run expectancies, frequencies, and the run starts. So we're first going to look at the question, is there a relationship between batters' opportunities and their successes in converting those opportunities to runs? So we get this great scatter plot where we can see this really interesting trajectory with batters with larger run start values tend to have larger run contributions, but there's a wide spread. And I mean, even though this spread is wider than the spread with less run starts, there's a pretty wide spread across the whole plot. And then we can also add the labels in order to determine which players are really these top performers of getting higher run expectancies. And those names are listed here. The book didn't include it, but for general interest and continuity, I also plotted Altuve right here just to put things again into perspective. So we could also look at position in the batting lineup because, as we noted, that can have a big impact on the opportunities that a player is given. So we're going to evaluate that run value criterion in relation to the batting positions. And a note here is that the frequency of a player within a batting position is used to define their batting position, even though that may not be consistent at every moment. The most frequent position they're in is the one that they're getting labeled with for this assessment. So the book created a scatter plot with the numbers. I added colors for the numbers to make it a little more visible and differentiate those numbers a little bit. And we can see here in red and blue, most of our first and second batters create fewer runs than our third and fourth, which makes sense given that the opportunities that are available. This line in red here is just 0, so we can easily differentiate between negative and positive here. And we can see really the best batters are usually third and fourth. We have some second batters up here as well, which I thought was really interesting. And our big blue dot here is Altuve. I also subsetted the plot to only look at third, fourth, and fifth to really nail in those best hitters, quote unquote, a little better. And I thought this was really interesting to see, especially these third position hitters really have a more increased run starts, but also do really get these higher run expectancies. And even though our fourth and fifth batters are fantastic here, they really don't commonly reach this same run expectancy that the third position batters do.
I did have a question about this one. Just in terms of like confuser variables, as it were, right? Because this is the run. This is how many runs beyond their run expectancy, right? That they get for the year. So even like the guy that's batting third or fourth, he probably is in a position to have better run expectancy, but we've already taken that into account by subtracting off how many runs they're expected to get. Am I saying that right? Or am I just confusing?
I think so. Let me. Yes, no, I think you're right on that.
And so, but still, even though you subtract that up, I still think there's a lot more variance for those guys. Like they have more chances to get lucky out there, maybe in the fourth and fifth, because now they're more likely to see those high leverage positions, right? Where even though there's already a high run expectancy they have to reach, but they're probably have a lot of opportunities to go beyond that because there's a lot of variance in there. I guess there's a lot of possibility to go below it too, so maybe that cancels out. I don't know. I'm just kind of thinking out loud. When I read this, I'm like, I'm not sure about that. I'm not sure about the conclusions they're drawing there. Are the better players batting third or fourth, or the people that bat third and fourth are got a better position and then they look better? That's what I guess what I'm trying to say.
Yeah, I mean, that's a really great point. And I think, from not being a baseball expert by any means, I mean, I understand the game, but I feel like it's probably a combination of the both, right? Like people who are seen to hit better are probably more so put in that position, but then also are given a better position to have, better luck and higher run expectancies.
Yeah.
Yeah.
But now that I say it out loud, I guess it is a two-way street. And if you put a not so good player there, you're going to have a big negative run experience. Batting below your average, what do you expect? Then it could be a big, that was because our run expectancy there is like whatever it is, 0.3, and you never even get any runs. So
Yep, that definitely. I think you're right. Two-way street is probably
yeah.
right. And one of the things that I think is really interesting about looking at this data and the analytics is really that factor specifically is that these are humans and this
Yeah.
is a sport. So there's so much intertwined to really look at that you could go really deep with parsing apart within
Yeah.
analytics because of all these factors.
Okay. Anyway, that was my observation for that.
No, I love it. That was great. Okay, but yeah, again, here's our blue dot. And Altuve is in the top hitters in terms of creating runs. And yeah, very interesting to look at batting position with all of these factors. So going a step past that, we can look at the value of a home run and then we'll look at the value of a single, but home run is a little easier to assess. So our batting average gives equal values to all possible base hits. And the book output this nifty little table with all of the possible states. Again, this is our 3 bases and how many outs there are. We can see that there is a high frequency of no one on bases and 0 outs. But again, looking at a chunk of numbers is interesting, but not very initially intuitive. So I created another heat map here. And we can really see that base counts are high for nobody being on bases for these various states, followed by someone being on first, which kind of makes sense there. So as great as frequencies are, their sample sizes, their frequencies, their counts. So I thought it was interesting that the book also calculated the proportions. I think that's a slightly better representation to look at, but our heat map stays the same. We have higher proportions on these. No one on bases, followed by someone on first. And given this, I also assessed by bases. We can see that over half of the home runs are hit with no runners on base. So what's the run value of a home run then? We can look at the mean of the run value and we get 1.38 as the mean run value of a home run. And then we have a plot with the frequencies where our run value is on the x-axis, our frequency is on the y. And again, this relates to that one run value of Jose Altuve that we put the little box around is indicating our home run. And we can see that that is the most frequent occurrence, most frequent run value. And to give a little extra perspective here, this big red line is the mean run value. Let's really take a look here. Very interesting to see this low frequency of very high run values, but we've got some variation within here. So we can then look at which runner out situations lead to the most valuable home runs. The way we did the multiple ways to do this, but the way the book did was by taking the data frame and arranging in descending order so that our highest run value is at the top. And then just taking that top row. And we can see that the most common, sorry, not the most common, the highest, most valuable home runs gets a run value of 3.41 when the bases are loaded and there are 2 outs. And then somebody hits a home run. So our new state is no one on bases and 2 outs. This intuitively makes sense, but it's really cool to see the actual data and the run numbers on it. So digging into the value of a single, the reason this is a little more to consider here than a home run is that the final state of a home run is that bases are empty, right? Everybody comes in whenever you hit a home. The final state of a single depends on the movement of runners on bases. So we have this frequency histogram here where our run values are at the bottom here and our frequencies are on our y-axis. And again, we plotted this mean run value from previous. And we can see that the most common run values are just shy of that mean, between, I don't know, 0 and less than 0.5 here. And looking at that same state table here, and I made the same heat map of the various bases and outs of our various states. Again, our frequencies are highest with nobody on bases and followed by somebody on first. And once again, I created the same by basis plots, and we can see there's over 15,000 occurrences of singles with nobody on bases. So what's the most valuable single from the run value perspective? Again, we arrange by descending value. So our highest run value is at top. Select our interesting columns that we want to look at and take that first row in order to look at our most valuable single. And that most valuable single has the run value of 2.68, where the initial state is bases are loaded and there's 2 outs. And the new state is that there is only someone on third with 2 outs. So we got 2 people in and we've still got 1 on third. We got 3 people in at that point. There's our hitter got to third. So the book talks about this situation a little more, and it says that the baseball reference notes that what happened in this particular situation is that the center fielder made an error on fielding, and it allowed all three runners to score and that batter to reach third. So also nice and interesting to put the story behind the numbers. I think it's an interesting ad. Looking at the smallest run values next, we arrange in the opposite direction so that our smallest value is at top and select that row. And we get the smallest run value is negative 0.62, which occurs whenever somebody is on second with no outs. And then somebody's on first with one out. So our person on second got out, our batter ended up on first. The story behind this one is that a runner on second was hit by the ball in play and was called out, which created a negative run value, which was I think a funny situation. So the big highlight of all this is that the benefit of the single really depends on the advancement of the runners. And based on our current state and our new state, that can be calculated with our run values. So finally, we're looking at the value of base stealing, really trying to decide, is there a net benefit to attempting to steal a base? I thought this question was interesting, but could probably use some caveats, is that it's not just a benefit of attempting to steal a base for anyone in general, right? These are professionals who take very calculated risks and know the game very well. Um, and you can see that through these numbers, and that only 24% of the instances somebody is caught stealing, but most of the time at over 75%, the base is actually stolen. But fun to see those distributions as well. So, what are the common runner out situations for attempting a stolen base? We have a frequency table here, and our most common occurrences are when somebody is on first, either 0, 1, or 2 outs. Um, and that's followed by somebody on first and third. So the corresponding run value really reflects the success of the attempt, which we can see a little in this plot here. We have our run values with a very clear distinction between positive and negative run values, simply based on whether the base was stolen or whether the player was caught stealing. Where most frequently the base is stolen and we get a slight positive run value. But whenever you're caught stealing, we commonly have a negative run value. What I thought was particularly interesting here is that even though these frequencies are high and very distinct for positive and negative run value based on whether the base was stolen or you were caught, there are still these little instances that can be a little difficult to see in this plot, but you can see there's a little red here of caught stealing where we still have positive run values. And there are still a few little instances where you can steal the base successfully, but still have a negative run value impact. So focusing on the stolen base attempts, this is the code in the book is looking only at a state of someone on first and one out for this section. And in that case, our caught stealing situations end up at almost 30%, and stolen bases bases are stolen successfully at about 70%. So we have this breakdown of new states where the percentage is highest for somebody being on second and one out for that new state. I actually had a question here, if anybody has the answer. So this is looking at an initial state of someone on first and one out. How then do we have a new state of no one on bases, but still have one out? Now, this only occurred once, so this obviously is a very rare situation. But I don't quite understand how our person on first is no longer there, but we don't have an increase in outs.
Was there a run?
Oh, that makes sense. If there was the batter hit a home run, they both came in. That tracks. Thank you for that. I don't have the data or the story
Okay.
behind it to confirm, but that's what I would assume happened. But very interesting to think about. That's a very rare case, but could happen. So looking at the value of attempting stolen bases in this particular situation, so we're looking at the mean run value of somebody on first and one out, and that mean run value is 0.007. So small overall mean value, but stolen bases are often worthwhile, particularly as they are very often successful with our 70%, 75%. But again, the benefit really depends on the success and failure of the bases being stolen and the runner out situation, which again ties back to our discussion earlier of this being a sport and very human. And, we have these great numbers and these great analyses to really dig in and are very helpful. But a lot of things just depend.
That seems really small though, right? I mean, that's per stolen base. So what did they say? You had to get like 10 extra runs. What was the rule of thumb? 10 runs gives you another win. I forgot what it was. The rule of 10, I don't know what it was, but
Ricardo's nodding, so I think you're right
Yeah.
on that.
10,
and so
around 10 runs, equals a win. Yeah.
so
That's
to
what we
get
learned in
10
chapter 4. Yeah.
yeah, so to get 10 runs, you need like what? 100 attempts, still
Yeah.
150 attempts at stolen bases.
You need a lot of stolen bases. Yeah.
Yeah. Well,
Now, this is subset to only
1,000, I guess.
situations where somebody's on first
Yeah.
and one out. So that's not like all stolen bases situations, but yeah, it is a small number for even just this situation, I would think.
I mean, I think if I was a baseball analyst, I'd be like, hey, don't, this is put you in a high variance situation for no reason for a little win, unless you want to
Right.
gamble. It's a
Small
gamble.
impact.
Yeah.
Yeah.
But it might be situational too. Like there may be situations where like, this team, this pitcher is really got a blind side over there and he's never going to catch you and you got a much better success rate or something. Yeah. So this is kind of like on average. This tells me maybe they're not that good at judging those situations.
Also, think about situational, scenarios here.
Yeah.
I wonder, how the pitcher, if it's a left or a right pitcher, contributes to that.
Mm.
Because the left pitcher is looking at you, okay? The first
Yeah.
base. The right one is the one that is not looking at you. So that will be interesting to see if those at the caught stealing, the pitcher was, a left hand or else.
That's a really good point too.
Yeah. I mean,
I wonder.
you seen the game, the left hand pitcher is just looking at you, and sometimes they get lucky.
Yeah. That makes
The
sense.
catcher throws a bad throw, and he gets the base. But it's harder. It's harder if it's a left hand and a right hand. I would assume.
Mhm. Yeah, I love this point of, if you understand the stats of the players on the other teams, that could even benefit your, in-game assessment of what would
Mhm.
work and be better risks and stuff. I'm not super familiar with the career space of sports analytics. I wonder if that's something that is commonly employed, like analysts will be on a team and evaluate another team's stats in order to further inform, the players on their team. But yeah, that's a really interesting point.
I mean, I assume that's what they're doing. I mean,
Right.
they've got relatively big teams. I mean, there's a guy I can't remember his name. Shoot. Anyway, it fell out of my head, but he's the guy that does the Learning Bayesian Stats podcast, which I listen to, and he works for the Marlins, the Florida Marlins, and he's got like a team of like they're looking for more people. Even there, they got. I posted earlier in the Slack. They're looking for more people. So that's just one team. There's many of them that have these relatively large departments now. Makes sense, right? There's so much data. We're looking at just a piece of it, and there's so much data. It's got to be a lot of opportunity to do. His name is Alex Andorra. That's what it is, and yeah, he's like one of many people doing this, so I assume that there's a lot of that going on.
Yep, that makes sense. That's a big team of analysts, which is really cool. Well, that's all I had. I didn't go through the exercises, but yeah. If anyone else has other thoughts on the chapter, I'm open.
I didn't go through the exercises either, actually, but I meant to. I just got so swamped this week. It was supposed to be crazy, but I will try to before we get to next week. Looks like there's some interesting ones there, but I mean, there's all kinds of questions you can ask with this. I didn't never heard of this run expectancy thing. That's new to me, and I thought, oh, that's a nice way of looking at it. And I can see how you could tie that into the wins, right? That we just were thinking about earlier. Well, I mean, you get 0.07, runs. How many wins is that? Well, we have this other thing about how the Pythagorean theorem, so it all kind of ties together. They hinted a little bit that that's how that war wins above replacement thing has kind of worked out. Trying to figure out like how many wins is this player really worth for a season?
Right.
Mm-hmm.
Extra wins, I should say. I thought that was all very interesting.
Yeah, this value of run expectancy was new to me too, but it seems like something too that could potentially be used for a variable in other more intensive analyses as well to account for, I don't know, variance or expectancy predictions, Bayes maybe.
Yeah. Yeah, for sure. I mean, it's like this is an interesting game. I listened to somebody else talk about this the other day, and he said baseball is a game of billion-dollar companies trying to eke out some value out of billion-dollar players, and it's just like, and so there's a lot of analysis goes into figuring out the value of the players themselves, like whether it's worth investing more in them or not, or trading them, or putting them in development, or drafting them. I mean, just it's a really interesting industry.
Yeah. Does anybody know how widely spread data is, especially more recent data because especially thinking about this, right? The monetary value, the determining other players' patterns in order to kind of get an edge for your own team. It seems like the data would be closely guarded in order to avoid, giving too much information out to somebody who may use it against your players or team.
The sarcastic answer is that all teams except the Colorado Rockies have data analysts. But a more realistic answer is that there are some baseball firms that do service multiple franchises just because they could pull resources.
Mm-hmm.
That makes sense.
I mean, as far as the data, I think a lot of it's like the StatCast people, right? Or not,
Right.
is it, they
Right.
only,
That's what I was thinking. Like, in stock trading, for example,
Mhm.
uh, the data is ready available. The trick is to kind of,
use it. Yeah.
use your own metrics, get your own metrics, get your own intuition, to get kind of an edge on that,
Yeah.
Mhm.
particular field. And for example, in stock trading, what you want to do is just make a little more money, out of what you're investing. Here, what you want to do is trying to get the most wins out of the scenarios that could appear,
Mhm.
eventually, because we haven't talked about injuries, you haven't talked
Oh,
about
yeah.
managers, getting fired or getting, retired, whatever. The manager is also. I think there was a in the last chapter. I saw one of the members draw, the wins, but by manager, and that's
Yeah.
something that is
Mhm.
really important because you can see all this performance of the players, but sometimes that kind of managing, that soft, skill of managing and getting most of the people also gives you an edge. So I mean, it's a combination of all the things that can get a team to to win a World Series, really.
Mhm.
Cool.
Yep.
All right. Well, I think I don't have anything else. I can push the end button unless anybody else has something. The end button being typing out the word end. Going once, going twice.